for lunch, which means we got a long way to go. And that's fine. My goal is, you know, I used to like just speed through my slides. It's like, hey, if you can keep up, that's great. But if not, we're going to go anyway. So I've obviously slowed down the pace. But I think that's to everybody's advantage. So again, there's a basic protocol. I've published this just last year in a review article. I've published it a couple times, but this is like the newest version of it. You can get that from my website. And it helps people get off of this pro-inflammatory track that most people are on. If you look at the dietary patterns of most Americans and people in so-called industrialized nations and people who we force industrialization on, they end up consuming a diet that's pretty high in high sugar foods, fructose, glucose, sucrose. And so what's the effect of that? It causes immune suppression and oxidative stress for about 4 hours, so it's no surprise that we see a lot of chronic infections and chronic inflammatory disorders. Typically the foods are high in fat, especially as we said before, trans fats and or saturated fats. Some things you have to know about saturated fat. So earlier I talked about hypothalamic inflammation. One of the ways to create or induce hypothalamic inflammation is by feeding animals and theoretically therefore humans saturated fats. Saturated fats activate a receptor called TLR4, which stands for toll-like receptor 4. So TLR4 is one of the major inflammatory, let's say, pathways or gateways, and it's activated principally by two different agonists. So if we want to talk about what is the activator of TLR4, the two answers on my exam are going to be microbes and saturated fats. So another way of saying that, TLR4 presumably was meant to receive microbial information, so to speak, and help modulate the immune system's response to that. But if that's true, and it is true, then another way of saying this that I'm trying to say is that the body responds to a high saturated fat diet as if it's fighting an infection. So, and one of the pathways that gets activated is TLR4. That causes hypothalamic inflammation. In a state of hypothalamic inflammation, the body is more likely to deposit fat. So part of the reason we want patients on a low saturated fat diet and or we want to supplement them with omega-3 fatty acids and omega-9s in the form of oleic acid is we're trying to reduce hypothalamic inflammation that's been induced either by microbes or by saturated fat, right? So if you put patients on a low saturated fat diet and or if you address their chronic microbial infections, then that can help them lose weight. High fat foods, as I just mentioned, fatty acid imbalances. Most people don't get enough ALA, EPA, DHA, and GLA. Therefore, no surprise that we see this abundance of inflammatory conditions in our practices. And inflammatory conditions can be anything that you think of. Parkinson's, Alzheimer's, cardiovascular disease, diabetes, in addition to allergy and autoimmune conditions. And as you will come to appreciate as we continue this conversation, you know, in the past, I think we thought of fatty acids as having an anti-inflammatory effect or blocking cyclooxygenase or lipoxygenase. And then, of course, we certainly thought about EPA and DHA as having roles in the brain because DHA is concentrated preferentially in retina and the brain, for example. But I think we also have to appreciate, for example, that DHA from fish oil plays an active role in mitochondrial function too. So there's an enzyme it's involved in the Krebs cycle as well as in the electron transport chain called succinate dehydrogenase. And succinate dehydrogenase is actually adhered to the inner mitochondrial membrane structurally. And the way that it adheres to the inner mitochondrial membrane, I believe, is through the fatty acid, or yeah, it's not really fatty acid, but it's cardiolipin. And one of the main components of cardiolipin is DHA. So another way I can say all that, having just reviewed the structure, is DHA is necessary for proper mitochondrial function. DHA is the anchor for the enzyme succinate dehydrogenase, and two components of that anchor, well, it's a component, DHA is a component of cardiolipin, which is the real anchor. So in other words, if patients don't have enough of these fatty acids, their mitochondria are not going to work optimally. Because if there's no DHA, there's no cardiolipin. If there's no cardiolipin, then the enzyme succinate dehydrogenase, which actually is present both in the Krebs cycle and in the electron transport chain, the enzyme can't function optimally. So in order to optimize mitochondrial function, we have to optimize their fatty acid intake. See, that's just more detail than you get in the notes. Sure, go ahead.
For saturated fatty acids, are you delineating medium and short chain versus long chain?
Good question, and mostly good question. So mostly when I talk about saturated fats in this global sense, in the pro-inflammatory state, I'm talking about long chain saturated fatty acids. Some of the shorter chain ones, like from coconut oil and things like that, not so bad. Vitamin and mineral deficiencies are rampant, especially magnesium and vitamin D. I'm sure for those of you who are actually doing vitamin D testing, I'm sure you find most of your patients deficient, right? If you look at studies done in Florida and Arizona, which are obviously the southernmost states where they get plenty of sunshine, they still find people vitamin D deficient all the time. When I was in my 4th year of medical school, we tested vitamin D levels in 157 patients coming to our rheumatology clinic, and out of 157 patients, 156 of them were deficient. So we only found one who had what I would consider to be optimal vitamin D status. So in other words, your patients are very vitamin D deficient unless you're supplementing them and testing them and monitoring them appropriately. Allergens, a lot of people develop food allergies. So what do we do about food allergies? First of all, we have to be aware of them. Second of all, we can do elimination challenge for patients who are allergic to whatever it is they're allergic to. But there are 2 other steps we can take, and that we'll talk about as today goes on. Anytime you're dealing with a patient who's got multiple allergies to foods, you obviously, I hope, are starting to think in terms of leaky gut. And therefore, if you're thinking leaky gut, then you have to think of what causes leaky gut, right? So it's not enough. I mean, it's great. It's a great advance to at least think about leaky gut, because obviously the medical profession mostly doesn't. But you have to, go beyond that. And then if you have a patient who you think has leaky gut, you have to know what causes leaky gut, right? So how many, at least in my books, there are 6 causes of leaky gut, 4 of which you can exclude by history and physical exam alone. So then that only leaves 2 that you have to guess about. And the 2 that you have to guess about are food allergies, because leaky gut causes food allergies, but food allergies also cause leaky gut. So it's a vicious cycle there. And the other thing is gastrointestinal parasites. And when I say parasites, I really mean dysbiosis. And when I say dysbiosis, I mean anything that's growing in their guts that shouldn't be there, whether it's bacteria, amoebas, other protozoas, or fungi. Now, we'll go through some cases. Insufficient phytonutrients. If people aren't eating a plant and vegetable-based diet and they're not taking like a phytonutrient concentrate, then they are deficient in phytonutrients. And therefore, what would be the expected outcome of that? They're going to have more inflammation, pain, and oxidative stress. And their mitochondria aren't going to work as well. Insufficiency of fiber. I mean, the most obvious consequence of that is increased risk for colon cancer and increased risk for constipation. If people are constipated, then they're not detoxifying on a regular basis. They're going to develop, or at least they're predisposed to develop bacterial overgrowth. They're predisposed to develop, absorb more toxins from their gut. So we want our patients having a good bowel movement at least every day. Twice a day would be nice. And you can promote that through plant-based diet. Make sure they're on vitamin C, 3 to 6 grams per day. That'll help hydrate their stools and help them have bowel movements. Make sure their thyroid status is sufficient, and make sure they don't have bacterial overgrowth of the small bowel, which actually promotes constipation as well. Foods that promote bacterial overgrowth: sucrose, wheat, potatoes, and lactose and dairy. So just a few minutes ago when we were in the break, I was talking with someone about gluten allergy and celiac disease and all that kind of stuff. I personally, for the most part, don't care if my patients have wheat allergy or celiac disease, because I don't want them eating wheat anyway. So if a patient comes into my office and says, look, I don't have celiac disease, I don't have to follow your dietary recommendations, then we have to sit down and talk about that. Because, number one, I'm right. And they need to not eat wheat, right? So regardless of whether a patient has or doesn't have celiac disease or an IgA or IgG or IgG4 or IgE antibody to gluten, it doesn't matter. Like I said before, part of what we have to think about when we're discussing food intake is we have to ask, what is the effect of that food on overall physiology? Not simply looking at vitamin and nutrient content, not simply looking at carbohydrates, fats, and minerals and vitamins, but looking at what is the effect of this food in the human body. And when we look at the effect of wheat, regardless of whether a patient has celiac disease or wheat allergy, the fact is wheat promotes bacterial overgrowth of the small bowel, and that's a major problem. Especially if you're dealing with patients who have rheumatoid arthritis. So what percentage of patients with rheumatoid arthritis have bacterial overgrowth? I think it's somewhere between 40 and 80%. What percentage of patients with irritable bowel syndrome have bacterial overgrowth? At least 80%. What percentage of patients with fibromyalgia have bacterial overgrowth? According to some studies, it's 100%. Right? So if you're not treating bacterial overgrowth and if you're not addressing that, you might be getting great results, but you could probably get better results if you were to address that component of their problem. And one of the ways to address it is low carbohydrate diet, specifically avoiding grains and potatoes, and then using some type of orally administered antimicrobial like berberine or oregano oil. Those are two of my favorites. Dysbiosis, we'll talk about this more this afternoon. A lot of people, of course, don't get enough exercise. You know, the recommendations these days, even from the government and the CDC, Centers for Disease Control, is an hour of exercise per day. 5 days a week of aerobic exercise, and then 2 days a week of resistance training. When people exercise, they release certain cytokines from muscle called myokines, which have an anti-inflammatory effect. And obviously, they're building muscle, and they're reducing insulin resistance. Xenobiotic accumulation, of course, is pandemic. Everybody in here and everybody in the country and all of your patients have some level of toxicity, whether it's heavy metals, chemicals, or both. And that's especially true for patients who are overweight and diabetic and who have Parkinson's. I mean, Parkinson's is the classic example of chronic chemical toxicity. And of course there's a genetic component. And of course we don't have all the answers. But if you look in the brains of people who have Parkinson's disease, they have high levels of a pesticide called Mirex, which happens to be a mitochondrial poison. I don't think it's a mistake that it's there. Emotional stress and toxic relationships, of course, those have to be addressed as well. So here's a diagram from my book, which is, I actually learned this in philosophy class in chiropractic college. So one of my teachers at Texas Chiropractic College before I transferred to Western States was Dr. Ward. And I was so glad I actually showed up for class this day because he gave us this analogy, which for him was kind of like a teeter-totter. He said, you know, you eat a candy bar and your health goes down, you get adjusted and your health goes up. And ever since then, I started to look at health in terms of balance. And so here's my visualization on that. And what we try to do in functional medicine and integrative chiropractic, et cetera, is we try to get people off of the Western lifestyle and we try to get them on to what we can call a wellness lifestyle. And if you look at the wellness lifestyle, it's basically what we're going to talk about today. Healthy diet, nutritional supplements, and then lifestyle and emotional health. Whereas if you look at the items in the disease-promoting category, that's the way most Americans live. So is it any surprise then that their health is always declining and that we have to do this bubblegum and baling wire approach to healthcare just to kind of keep people out of the drink? So the components of diet that we're going to talk about right now: food-induced inflammation, oxidative stress, immune suppression, phytonutrient deficiency, sugar and insulin excess, GI dysbiosis, including bacterial overgrowth, deficiencies, and allergens. We already looked at this slide, so I won't go through it again. It just reviews the basic 5-part protocol. This was a great article written by my friend David Seaman, who I'm sure you all know, and he wrote this in JMPT. And the journal was barely willing to publish this article because it was radical and it suggested that people actually need to modify their diet in order to treat inflammatory conditions, right? What a concept. So this was published almost exactly 10 years ago. I thought David was obviously very progressive in his thought. And now, 10 years ago, this was a radical idea. He even published it under the guise of a question. But now we take this for granted, right? So a lot's happened in 10 years. And now we understand the mechanisms down to the molecular level. So unhealthy diet promotes inflammation. Grains, especially wheat. If you could get your patients off of any food, it would be wheat, right? So, and I've got a slide on it, so I won't go through it right now. But if you just scan that paragraph, you'll see that I talk about the Maillard reaction. And then we can consider any grain to be a refined carbohydrate. And when we talk about simple carbohydrates, we have to appreciate that they actually promote oxidative stress, antioxidant depletion, and immune suppression. And all of those things occur through affecting mitochondrial function. Lack of fruits and vegetables, nuts, seeds, and berries equals lack of fiber and other nutrients. It also means that pretty much by definition they have unhealthy gastrointestinal flora, which we also have to modify. A lot of patients, in my opinion, actually don't get enough protein, so I always want to make sure they're getting enough protein. So what would that be? At least 0.5 gram per pound of body weight, and if they're athletic and training, then probably 1 gram per pound of body weight. And I am saying 1 gram per pound. So like for me, I weigh about 215 or so, I'm trying to hit somewhere around 200 grams of protein per day, so that means 4 meals of 50 or 5 meals of 40, something like that. It sounds like a lot, but if you look at the research, in particular this article that was written by an author whose last name is Lemon, that's what he recommends, and based on that article and a few others, they all came up with the same number, which was for competitive level athletes, 1 gram per pound of body weight. So anyway, that's what I recommend. Doesn't mean they have to get there. They could be 0.8 grams per pound and that would still be okay. But I like for people to get enough protein. Most Americans consume too many omega-3 fatty acids, or sorry, too many omega-6 fatty acids. What would that be? Like vegetable oil, linoleic acid is the classic omega-6, which actually promotes oxidative stress and inflammation and increases the risk for breast cancer in women, even though it lowers cholesterol. And arachidonic acid. So where do people get arachidonic acid? Mostly from animals, if those animals were fed grains. But if we're using like grass-fed beef, it's, the fatty acid profile of grass-fed beef is just as good as salmon. So certainly people can use grass-fed beef, but grain-fed beef means it's going to be rich in omega-6. Eventually that's going to mean it's rich in arachidonic acid, and arachidonic acid is clearly pro-inflammatory, right? It screws up calcium-magnesium balance within the cell. That promotes inflammation because it promotes high levels of calcium within the cell.